So this video is to go over parabolas again. You've done parabolas many times in Algebra 1 and Algebra 2, but we're going to look at parabolas as a conic shape in pre-calculus. So I'm going to go to page 98 at the top and walk you through some notes. So I'm just going to read for a second. The definition of a parabola is a set of all points x, y on a plane that are equidistant from a fixed line called the directrix, and some fixed point focus not on the line. So let's just go over these parts really quick. So you are used to a parabola having this red axis symmetry. It's the vertical line that cuts the parabola in half. You should also be used to the vertex of the parabola. And now we have this thing at the end called the directrix. The directrix is perpendicular to the axis of symmetry. And then this distance right here, this distance here and this distance here are going to be the same distance. So from the vertex to the focus is going to be the same distance as the vertex. This is the vertex. The directrix is going to be the same distance as the vertex to the focus. The vertex to the focus, we call this distance P. And down here we call this negative P because we went the opposite direction. So we know where the vertex is. We know about the axis symmetry. The directrix, like I told you, is perpendicular to the axis symmetry and it has the same distance. Vertex to focus is the same distance as vertex to directrix, but they're in opposite directions. So let's go on to the next page. And by next page, I meant my next page in the video, but not your next page of notes. I'm still on the bottom of page 98. These are the formulas you're going to need to know. You're going to need to know that for a standard up and down parabola, we have these formulas. I'm going to explain those in a second. And for a sideways parabola, we have these two formulas. I'm going to be really honest. I don't memorize these two special cases. The special case is where the vertex is at the origin. And if the vertex is at the origin, then HK is 0, 0. And so all they're doing is plugging the 0, 0 into the formulas and simplifying them. But we don't need to memorize that special case. I'm going to talk about these two blue ones. So for this top one, I'm just going to give you some hints on how I remember it. So you're used to vertical parabolas, ones that go up and down. They always said y equals x squared. So the thing that's not squared is the direction that I go. So the y is not squared. So on this one, I go up and down. So when I look at this formula, x minus h squared equals 4p y minus k. This is the same formula you had before. I'll show that in a second. But this h and k is my vertex. And then this thing right here, that P, is that distance from the focus to the vertex. How long was that distance? And you just plug it in. I do want to show you one quick thing. Just for fun. I'm going to take this formula that we had right here, and I'm going to multiply it out a little bit. Or rearrange it is probably a better word. So I have x minus h squared equals y, not y, I forgot the 4p, equals the 4p y minus k. I'm going to divide the 4p over. So I'm going to have 1 over 4p x minus h squared equals y minus k. And then I'm going to add my k back over. So 1 over 4p x minus h squared plus k equals y. You're used to this. You've seen y equals a x minus h squared plus k. That is your formula for a parabola in vertex form. All we've done is replace the a with the 1 over 4p. So we can do this. Same idea on the other equation, this one right here. The only difference is y minus k is now squared equals 4p x minus h. So now because the y is squared, this is a parabola that's going to go side to side, not up and down. but everything's still the same. The H and the K is still the center, or sorry, the vertex, and that P is that distance from the focus to the vertex. So on the next page, in your physical notes is page 99. You're going to have to go back to Canvas and open the other video, but I want to give you a rule first. So for this whole new unit that we're in, circles, parabolas, and then next week will be ellipses and hyperboles, there's 2 rules, okay? 2 rules, and if you follow them, you're going to be very successful with conic sections. Rule 1, determine the shape. That will help you know what formulas to use. And once you know the shape, 2, you need to draw what you're given and determine the orientation. And by orientation, I mean, is it left, right, or is it up and down? Because again, like we just talked about, parabolas that go up and down have a different formula than the ones that go side to side. So if you follow these 2 steps, you should be pretty successful with conic sections.